Hold on to your seats, space fans. It's time to journey into the heart of the most dangerous places in the universe. From the deadly radiation and explosive power of supernova to the incredible gravitational forces of black holes, these extreme environments are not for the faint of heart. Discover the secrets of the universe and witness some of the most awe-inspiring and terrifying phenomena ever observed. So, are you ready to embark on the ultimate adventure? Watch the most dangerous places in this video now and find out. What is space? Space is a three-dimensional continuum containing positions and directions. In classical physics, physical space is often conceived in three linear dimensions. Modern physicists usually consider it, with time, to be part of a boundless four-dimensional continuum known as spacetime. The concept of space is considered to be of fundamental importance to an understanding of the physical universe. However, disagreement continues between philosophers over whether it is itself an entity, a relationship between entities, or part of a conceptual framework. Black holes. Black holes are one of the most intriguing and mysterious phenomena in the universe. These massive objects are so dense that their gravitational pull is strong enough to warp space and time, making them a force to be reckoned with. While black holes themselves are not inherently dangerous, their intense gravitational fields can wreak havoc on the surrounding space and matter. For example, if a star or planet gets too close to a black hole, the gravitational forces can cause it to be torn apart and shredded into a stream of gas and dust known as an accretion disk. Additionally, black holes can emit powerful jets of radiation and energy that can pose a threat to anything nearby. Even light cannot escape the gravitational pull of a black hole, making it impossible to observe directly and adding to its mystique and danger. Overall, black holes represent one of the most dangerous places in space due to their extreme gravitational forces and unpredictable behavior, making them a fascinating but potentially deadly subject of study for astronomers and astrophysicists alike. Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler, after decades of black holes being known only as theoretical objects. The first black hole ever discovered was Cygnus X1, located within the Milky Way in the constellation of Cygnus, the Swan. Astronomers saw the first signs of a black hole in 1964 when a sounding rocket detected celestial sources of X-rays, according to NASA. In 1971, astronomers determined that the X-rays were coming from a bright blue star orbiting a strange dark object. It was suggested that the detected X-rays were a result of stellar material being stripped away from the bright star and gobbled up by the dark object, an all-consuming black hole. How many black holes are there? Approximately 1 out of every 1,000 stars is massive enough to become a black hole. Since the Milky Way contains over 100 billion stars, our home galaxy must harbor some 100 million black holes. Though detecting black holes is a difficult task, and estimates from NASA suggest there could be as many as 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is dubbed the Unicorn, and is situated approximately 1,500 light-years away. The nickname has a double meaning. Not only does the black hole candidate reside in the constellation Monoceros, the Unicorn, its incredibly low mass, about 3 times that of the Sun, makes it nearly one of a kind. What do black holes look like? Black holes have 3 layers: the outer and inner event horizon and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in spacetime where the mass of the black hole is concentrated. Scientists can't see black holes the way they can see stars and other objects in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn into the dense creatures. But supermassive black holes, lying in the center of a galaxy, may become shrouded by the thick dust and gas around them, which can block the telltale emissions. What are supernovas? Like people. They are born, live full lives, and then die. Except, that's an oversimplification. Stars are giants, but they're also giant chemical reactions. Just like a fire, those stars will eventually burn through their fuel supply. The difference is that when a fire exhausts its fuel, it doesn't blow up into something multiple of its original size, nor does it collapse back on itself to form super-dense matter. Massive stars burn huge amounts of nuclear fuel at their cores or centers. This produces tons of energy, so the center gets very hot. Heat generates pressure, and the pressure created by a star's nuclear burning also keeps that star from collapsing. A star is in the balance between two opposite forces. The star's gravity tries to squeeze the star into the smallest, tightest ball possible, but the nuclear fuel burning in the star's core creates strong outward pressure. This outward push resists the inward squeeze of gravity. When a massive star runs out of fuel, it cools off. This causes the pressure to drop. Gravity wins out, and the star suddenly collapses. Imagine something 1,000,000 times the mass of Earth collapsing in 15 seconds. The collapse happens so quickly that it creates enormous shock waves that cause the outer part of the star to explode. That resulting explosion is a supernova. Do they happen often? Yes and no. With billions of stars across countless galaxies in our universe, there is a high probability of a star going supernova somewhere. It's just a question of whether we can see it. They are some of the brightest objects humans have ever observed in the night sky and are often seen in other galaxies. But supernovas are difficult to see in our own Milky Way galaxy because dust blocks our view. In 1604, Johannes Kepler discovered the last observed supernova in the Milky Way. NASA's Chandra telescope discovered the remains of a more recent supernova. It exploded in the Milky Way more than 100 years ago. One of the most famous supernovae to be observed by humans was the formation of the Crab Nebula. In 1054, Chinese astronomers observed an explosion in the sky. This supernova, dubbed SN 1054, was visible for 2 years before fading into what we now know as the Crab Nebula. Other cultures in Asia recorded the fantastic night explosion, but it was hundreds of years later before the work of pioneering scientists like Edwin Hubble linked the early Chinese texts to the astronomical event they observed. In all, 8 supernovae in the Milky Way have been identified thanks to written testimony through the years. Types of supernovas. Type I of supernova. We will start with the more common type U, which is what people normally think of when they think of a supernova. A star exploding due to old age. Type I supernova occur when a large star runs out of fuel, which brings it into a rapid collapse and explosion. Such a star is between 8 and 40 times heavier than our Sun. They are often referred to as core collapse supernova because that's exactly what happens. The star's core suddenly, in just a few seconds, collapses in on itself. Type I. The two Type I subclasses called IB and IK are similar to Type I's supernova in that all of them are produced by the core collapse of a massive star. They have their designation because in both cases they lost their outer layers already before the core collapsed, in a stellar wind during their red giant states, and are thus usually referred to as stripped core collapse supernova. Like onions already partially peeled, Type IB has lost its first hydrogen-rich layer, and Type IK has both its hydrogen and the next helium layer, revealing the carbon-rich layer below. Type A supernova. Quite differently, but similar to the smaller recurring nova explosions, a supernova of Type Ia will take place in a binary star system, where one of the stars is a white dwarf, and the other is a companion star which the white dwarf is busy stealing matter from. A white dwarf is the superdense remnant of a smaller star, less than 8 times the mass of the Sun, in the last phase of its life. It is the result of the slow shrinkage, over millions of years, of a red giant star, such as Betelgeuse in the constellation Orion, recently the subject of much speculation that it was about to go supernova. It's not. In conclusion, the universe is a vast and dangerous place, full of extreme environments and unimaginable forces.